Hello dear students, today I will discuss about predictor corrector methods. Predictor corrector methods, just in the previous classes we have already seen that the methods start from starting Picard's method, Taylor's method, and then Euler's method, modified Euler's method. All the methods generally for solving numerical solution, solving numerically solution of dy by dx equals to fxy. Generally, this type of differential equation is given. First order differential equation. Initial condition is given. Y equals to y0 at x equals to x0. This is given. Okay. Initial condition this. Just we have to find the solution of this differential equation for some value of x. Just find y equals to what for x equals to 0.2 or 0.4 or 0.8 or for 1. Means if we are given this condition, that means initial value is given. Generally curve of solution, just this is x0, so this is y0, that is this is the point, or curve is here. Now for this is x0, if this is 0, then for 0.248, if we want to find the point 2 at point 2, also at point 4, at point 8, at point 1, if we want to find value at here, then we can take this as a single interval, and if we want to find the value at this, at this, at this, at this, then at here, at here, at here, at here, means y at point 2, y at point 4, y at point 8, y at 1. Just we have to, if we want to find this value, then we can treat this as a h. But if only x0, this is suppose, and here x n, only one value is given here, then we can divide this interval in many parts, and in each interval we can find the value for y at here, at here, at here, and go to finally at this point. And also we can do it, the process, in taking it as a single interval, that is h. But h should be small, then value will more accurate. So the taking a step is on the depend on the given condition, given targeted value. Okay. In each interval we are doing process of all the methods generally. Clear? Here just we are trying to find the value of y at here by using this previous value. For getting at this point, just we should use the value at here, for more accurate value at here. We can also use this value for this, but we use this value, and this value is find by any of the method. And then for further value of y, we can use this value as an initial value. Okay, then we can get more accurate value at points. Okay, by Picard's method, also by Taylor's method, Euler's method, Euler's modified method. Okay, so just previous value is used for finding the value of in the next step. Okay, we know just like this. Here step means what? H equals to what? We take. Clear? Now here just 3-4 methods we have already seen. Now here predictor and corrector methods, just same type of process we have to do here. The predictor and corrector means by using the previous value, just for finding the value at point at 1. Okay, here 0.8, here 0.6, here 0.4, here 0.2, here 0. 1, 2, 3, 4, 5. 5 intervals are there. Just for finding the value at here, this is x0, this is x1, this is x2, this is x3, this is x4. That is here y0, y1, y2, y3, y4. In the predictor corrector methods, this type of process, just in the previous method, by any of the previous method, we have to first find, because in all the methods we have already seen that the only initial at the starting value in any interval, either you take this or this or this or this or this, just we use values of x and y at the initial point, and by using this value just we have to find all the values. Okay, single value, only single, x0, y0, that is sufficient. But for predictor and corrector methods, for finding the value of y at targeted value, previous 4 values are required. That is 4 points, selected points are required. At least 4 values. Okay. So 4 prior values are required, means 4 values of y for values, some values of x are required to find the next approximation y4. That is, if we know y0, y1, y2, y3, it is given. Then next, the 3 values, these are also required for predictor corrector formula. So predictor corrector formula means one is prediction and one is correction. Means just suppose we want to find the value of y at 0.8, at y4. Then previous 4 values are required for prediction formula. Prediction means just predict the value of y at here by using these 4 values, and this value will be purified. This value will be refined by using correction formula. Means if these 4 values are given, suppose given, okay, 4 values, there is a single value is given, suppose 4 values are given now at this point, then these 4 values are used for predicting the value of y by prediction formula, and this value, for the accuracy of this value will be refined by correction formula. 1, 2, 3 means just we have to correct this value. This is predict. We will predict this value by using formula which involve these 4 values. Okay, and corresponding value of f. And then just this value will be refined by using correction formula. So this is prediction formula and correction formula. So what is the formula for prediction or for correction? This is due to many other different types of formula given by authors, just like Milne's method. Milne will provides formula for prediction, for correction, and also Adams' Wasforth method just in our syllabus. Milne's methods. Milne's method is what? Milne's prediction formula and correction formula. Formula due to Milne's we will use for Milne's prediction formula. Similarly, Adams' Wasforth formula, prediction formula, correction formula, different type of formula. But for prediction and for correction. Okay, for after when we see that there is very less difference between predicted value and corrected value, generally, then we will suppose this is the final value of y4. Or when we see that for first approximation, not approximation here, first correction, second correction, third correction. When we see that two corrections gives just like same values, that will be the final value of y4. Okay? And if there is next interval, then just we can use these 4 values, accepting this. For y4, we use this 4 value. For y5, we will use this 4 value. Because 4 values are required for this formula. Okay? So 4 prior values are required for predicting the next value of y in prediction and correction formula. Prediction and correction formulas are given due to Milne's, also Adams-Wasforth method formula. Okay, so today I will discuss about Milne's prediction and correction formula. Okay, so if 4 values are given, just because we require 4 values, generally we will give just like this type of equation, and this is one value, and 3 value also we require. So this 3 value can be found by using any of the previous method. Picard's method you can use for this next value y1, and then next value, and then next value, in this interval, in this interval, in this interval. We can find from by using Picard's methods, by using Taylor's method, Taylor series method, by using Euler's method, by using Euler modified method, or Runge-Kutta method. Any of the method can be used for finding these 3 values, because we are given only this single value. For prediction correction method, prediction correction formula, we require 4 values. So if we are given only single value, then we have to find this 3 value by using any of the previous method. Generally, Taylor series method is preferred. Runge-Kutta method is also preferred, because Taylor's methods are mostly agree with the Euler's method, Euler's modified method, Runge-Kutta method. So the best choice is Runge-Kutta method. By using this, we can get this value, and then this value, and then this value. This 4 value, when we have, then we can use prediction formula for predict the value of y4, next value, and this value can be corrected step by step by using correction formula. That is the prediction correction formula. Now I will discuss about Milne's prediction correction formula. Okay, so this three value can be found by any of the method. So here generally Taylor series method is used. You can also Picard's method, you use Picard's method, Euler's method, Runge-Kutta method, any of the method. Okay, so if we are given like this single value, then our target, what will be the target? Finding value, three value, previous values, and then we will use prediction correction formula. Okay, so here Milne's predictor and corrector formula. We use Milne's method. It is Milne's method. Formula. What will be the formula? Okay. Here we are given this first point. Clear? Y equals to y0 and x equals to x0. This is first point. Clear? We have to find. Suppose we are taking a step h. Then first value is this. Then we have to find second value. What? y1. Because this is y0 is given. y1. What y1? y1 means x0 plus h. Because this is x0, then h interval, this is x0 plus h interval, x0 plus 2h, h interval, x0 plus 3h, h interval, x0 plus 4h, and so on, x0 plus nh. That is, this is our initial value. This is x0, this is what? x1 equal to this is x2, this is x3, this is x4, and this is xn. So here y0 means at this point value of y0, at this point y1, at this point y2, at this point y3, at this point y4, and so on at this point yn. That is the final value. If our target point is xn, x0 plus nh, interval h. Okay, h distance is there, step. Clear? Now, y1 means this, x1, x0 plus h, x1. So, we have to find the value. y1 means what? x1, that is what? x0 plus h. Similarly, y2 we have to find because 4 values are required for prediction formula. So, first value is this, second value this, third value this. What? yx2 equals to, and here what? x0 plus 2h. Or we can write also like this, y x1 plus h, just increment h from previous point, x1 plus h, x2 plus h, x3. So you can also write this x0 plus 2h. Now y3, just our target is finding this 3 value, because 1 value is given, this 3 value, 4 value are required for prediction formula. Milne's formula. What is the Milne's formula? Just we have to do for the process for finding the formula. Here just x1, x2, 3, so x2 plus h, that is what? x2 means x0 plus 3h, we can write also. This 3 values we will find. So we can make this type of table, this x0, x1, x2, x3, y0, y1, y2, y3. These values are required, 4 values. And also after finding these values, because first of all This is given by any of the method. We will find the value of y1, y2, y3. And then corresponding derivatives, because this is derivative, dy by dx, f, corresponding value of f, we can find f0. What is f0? f0 means fx0, y0 at the point. At this point, x0, y0, this is fxy. What is this? Derivative. We can also write like this: y dash 0. First derivative, f0. Slope of tangent. Okay. So f0 we can suppose at the first point, fx0. This value can be found by using this format, fxy. Clear? Maybe x plus y square, x plus xy into anything. So by using this we can find the value of this. After finding y1 by using this value, any of the method, so just y1, when we find value of y1 by any of the method, or the next point, then using this x1, because this is x1 and y1, we will get the value x1, y1, so we can find value f1, means what? Dash f dash at 1. We can denote like this. Okay. So this is equals to f x1 y1. Similarly, f2 f x2 y2, f3 x3 y3. We can find okay. So this is notation. So we can write like this here also. This can be written like what? Y 2 dash y 3 dash at the point. So generally we are using this notation. Okay, so this is not required. Y1 notation. This notation will be used. Okay. So just our target is what? This value is given. By using this value, we have to find the value of y1, y2, y3, and corresponding to x0, y0, we have to find f of f0. Corresponding to x1, y1, x1 will be this next point. So x1, y1, corresponding to x1, y1, we have to find the value of f1. Similarly, x2, y2, fx2, y2, y3, fx3, y3. This can be found from this format. So we are having these 4 values of y corresponding to 4 values of x, x0, x1, x2, x3. Clear? By using this value, these are the first now derivative. Here for finding the value y4, just next value. Here, due to Milne, Newton's forward interpolation formula is used. Because we see that these are value, this value, this value, this value. So forward interpolation formula can be used in place of where just we want to find the value of y4, just like this, y0, y1, y2, y3, y4 for finding at this point value. So these values are known. So forward interpolation formula, forward differences, for Newton's forward interpolation formula here used. Here it is not required the derivation of the formula. Okay, so just we remember the formula. How can we get the formula? Just see here in brief, very brief. Okay, how y4, because whenever we make the table, forward for first order, second order, third order table. Here y0, here x0, y0, and these are the difference. These difference are used in the Newton's forward interpolation formula for finding y4. This difference can be used because x0, y0, x1, y1, x2, y2, x3, y3 for interpolation formula can be used. So this formula is used. This is leading term, suppose, so that y4 equals to y0 plus integration of x0 to x0 plus 4h fxy dx. This relation comes from where? We know if we integrate this on both sides, 4 steps are there. So x0 to x0 plus 4h. So here also y0 to y0 plus 4k. So that is 4 places, the y4 value. So y4 equals to this y0 plus x0 to x0 plus 4h fxy. Now for f, we can use Newton's forward interpolation formula. How? For f, what is interpolation formula? Just we know interpolation formula. F, for suppose f is function of x and y, this is equals to first value f0, second value is n del f0, n minus 1 by 2 factorial del square f0, n minus 2n minus 3 by del 3 factorial del 3 f0. This is Newton's forward interpolation formula. Fxy equals to. Okay. And this formula can be used here. Means put this here and divide, distribute and integrate. And also remember that del f0 equals to what? Del f0 equals to del f0 equals to f1 minus f0 by forward difference. That means derivatives can be expressed as a value of function. This is value of function. So means express derivatives in terms of function values, functional values. Not here difference, neither derivative, just functional values. So this derivative can be transferred to functional values. This derivative also can be transferred to can be written as functional values. This derivative can also be written as functional values. Just take up to third difference here and differentiate and integrate of functional values. Then we can get the formula. Okay, so this is the process for finding the formula. So here process or derivation is not required. So just we can find by using this, putting value here and integrating. First of all, difference is just to functional values and integrating. We can get after some substitution, we can get values up to the taking up to third difference. We can get the value of y4 equals to y0 plus 3h by 4. 3h by 4 is there now. 4h by 3, sorry. 4h by 3. Okay. So this is our formula. Just remember it. Okay. 4h by 3. 4h by 3. And 2 minus 1, 2. 2 f1 minus f2 plus 2 f3. This. Clear? This is formula. 4h by 3, 2f1 minus f2, 2f1 minus f2 plus 2f3. Okay. By using Newton's forward formula, you can get this. And this is prediction formula. Milne's prediction formula. Clear? Milne's prediction formula. This is predicted value. So we write here P predicted this value of y4 due to prediction formula of Milne's. Okay, this is the formula. Because for prediction of y4, just previous 4 values are required. So y0, y1, y2, y3. Whenever we know y0, y1, y2, y3, then we can find this from differential equation. Then f0, f1, f2, f3 are used here. f1, f2, f3. This is y0. Clear? So this is prediction formula. For the first 4 values are known. Known. How? This single value is unknown. Then any of the previous method using, you can get y1, y2, y3. Generally Taylor series method or Jagdalpur method. Okay. So after finding these 4 values, we can use prediction formula for getting next value of y, just like y4. And in a similar fashion as derivation of prediction formula, by Simpson rules, we can also find correction formula. So Milne's correction formula can also be found as y4. Just by using these values, we have to find the value of y4 as a predicted value by using this formula. Now this value will be refined by this correction formula. And here, first correction, second correction, third correction, fourth correction we can do. And whenever 2 values are same, then we can say that the value of y4 is final value. Okay? So, correction will y4 c. This correction formula, corrector formula. Okay? So, this is equals to here y2 plus h by 3 due to Simpson, h by 3. Here 1 4 1, f2 3 4, f2 plus f3 plus f4. Here just 2 3 4, 2 plus 4, 3 plus 4. This is formula. F2 plus 4f3 plus f4. Okay, this is corrector formula, correction formula. Okay, y4 correction. This value should be correction. Here f4, what is f4? By taking this value, because here x1, y1, x2, y2, x3, y3. Here y4 is predicted, so y4 is this, and x4 will be what? Just like x0 plus 4h. So here just find after this stage, after using prediction formula, so we get what? x4 equals to what? x0 plus 4h. So this initial value of h we know, step, and 4 you can get x4, and similarly just here we get y4 this predicted value, just predicted value, use this y4, this x4, we can get f4. That is, find f4 by taking f4 equals to what? f of, by using this f4, yeah, x4 and y4, this predicted value, the value predicted value is used here. So f xy, x4 and y4, and you can get value y4. This y4 is used here. Okay. Now, first time use correction formula for this. Okay. Then second time also you can use this value, because this is corrected value. For this value y4 and taking x4 is just like this. You can find f5. How? F x4 and we can get the value of just use this y4. Again, we can get also f4. f4 can be found by using this value. First time by using this value, second time using this value here. That means f of what? x4 and y4 corrected value, first corrected value. And similarly, y4 you have to find x4 and y4 second corrected value, and so on. And repeatedly this value can be used in this formula in the place of this f4. Okay. Then you can get further correction. And whenever two values are same, that will be the final value of y. Okay. So this is prediction formula, this is correction formula. General formula you can see, this is in one interval, just like y4 up to. Okay, now y5, suppose we have to find y5, just next value. Then we can use previous 4 value. Except this, y1, 2, 3, 4 can be used. So at that time, formula will be what? Slightly changed. Here 5, here 1, here 2, here 3, here 4, because previous 4 values are used. And here 5, 4, here 5, so here 5, then less, here 3, here 4, here 5. That will be the formula. That is, if we take here, in general formula we can write, because this is in first interval, and then for y5, the formula will be changed. Here 5, 1, 2, 3, 4. Here 5, 3, 3, 4, 5. So formula in terms of general formula, we can write here what? N plus 1. Here n plus 1, then here what we can write? N minus 3. Why? N equals to 3, 4, n equals to 3, 0. So here n minus 2, 3, then 1. Here n minus 1, here n. If we put n equals to 3, then y4, y0, f1, f2, f3. So this is general formula. Here also write in place of n plus 1, then just 2 less. So what? N minus, forgetting, here 4, here 2. So we can write n minus 1. If n equals to 4, then what will be here? N equals to 3, the 4, n equals to 3, the 2, and then just same value is here. n equals n minus 1. And here n minus just 2, 3. So n. Here n plus 1. N plus 1. So n equal to 3, then 4, 3, then 2, 2, and then 3, and then 4. 4 is used here. So this is general formula. Milne's prediction and formula and Milne's correction formula. This formula are used in each interval after 4 values are getting by previous formula. Then we can use this formula in next interval for predicting the value of y and correct. We can also correct that values by using correction formula. Okay, so this is the formula. Okay. Now take questions for finding the value of y, that is finding solution of equation by Milne's prediction correction formula. Okay, so we know the previous method are just like Taylor's series method and Picard's methods. Here are questions. Just take, given that, remember that due to the solving the questions, just I will write the value only. You have to calculate by using calculator. Okay, you can get the values just adding, subtracting, multiplying. Okay, u to the power something, log something, you can get from your using your calculator. Okay, and just write the value here. What is the process of finding values? Just see here. The solution of this question, okay, given dy by dx equals to what? X square plus y square to the power minus x square plus y square to the power minus x, y 0 equals to 1. This is given. Okay. And find y at x equals to 0.1, 0.2 and 0.3 by Taylor series method and compute y 0.4 by Milne's method. Okay. So here 3 points, 4 points are required. So here, how can you find the values of 4 prior values are required? Because here it is given that just we have to find the value of y at 0.1, at 0.2, at 0.3, at 0, 0.3, 0.4. This is our targeted value. Just find y4 by Milne's method. By Milne's method, we have to find this value. So this 3 value just given in these questions. If it is not given in questions, then you can use any of the method. They are given that this value is given 1. This. And we have to find the value of y.1, y.2, y.3 by using Taylor series method. You can use any method, Euler's method, use modified method, Picard's method, Taylor's method. And here just Rangagutta method. Here it is given that you have to find from Taylor series method. Okay, so our interval is what? Just like this: 0, 0.1, 0.2, 0.3, 0.4. This is our targeted value y4, y4. This is what? x0, x1, x2, x3. Corresponding value y0, y1, y2, y3. This three value will be found by Taylor series method first, and then this y4 will be predicted by Milne's method. Clear? So first of all, we have to find y1, y2, y3 from Taylor series method. By Taylor series method, we know in Taylor series just we have to write what in this equation. Just first of all, we have to express Taylor, write the expansion of Taylor expansion about this point. Then we will find this value. When we will find this value, then we can expand Taylor expansion. We can get Taylor expansion about this point or this point, any. If we expand about this point, because at first interval, just in the Taylor series method, we expand function about this point. Okay? And we find the value of y at here. At the time of finding of value this, just we have to expand about this point. But you can use the expansion about this point also for this. But if we expand the Taylor expansion about this point, then we can get better approximation at this point. So for predictor correction formula, the previous 4 values should be very accurate. So try to find accurate values. So here from Taylor series method, we have to find this at this, at this, at this. Okay. So just for this, first of all, we have to find derivatives, because in the Taylor series method, derivative should be find first, one by one up to third derivatives. Here, this is given, and also your fxy equals to, what is fxy? Your yx equals to, this is y, not yx, y dash, this y dash equals to. Okay, so just we can write y dash equals to y dash dy by dx means what? Y dash. So we know our first formula, Taylor's series expansion about x equal to x0, about first value 0, x equals to 0. Taylor series expansion about x equal to 0 is given by what? Y equals to, just you can write y equals to, yx equals to what? y0 plus x minus 0 upon factorial 1 y dash 0 plus x minus 0 square upon 2 factorial y dash double dash 0 plus x minus 0 or 3 upon 3 dash factorial 3 triple dash 0 and so on. Up to 3 derivatives just we have to find. Okay. So just one by one find the derivative, because Taylor series the main working is finding derivatives. So your first derivative is given. This is first derivative, dy by dx. So x square, y square to the power minus x. From here we can get this first derivative at 0. So first derivative at 0. Clear? How can you get at 0? X equal to 0. 0, 0, 0, 0. That means what? Will be the value 0. Clear? Now do the second derivative. Differentiate it. We can differentiate it. Just multiply. What first value? X cube plus x square y square. Multiply. First into differentiation of second plus just differentiate it, differentiation, first function into second function, first function derivative of second function, and then second function derivative of first function, this 3x square plus here x square y square, two functions are there. So this is first function, this is second function, so 2x y square plus x square 2, what will be the derivative? 2x square y into y dash. This is the derivative, second derivative. Now we can put 0 because at x, and we can get y double dash at 0. What? 1. It can be written also like this. Just complete it, you can see x equal to 0. So here x equals to 0, then this is 0 minus 1. Clear? Here y dash 0, 0, x 0, 0, 0, e to the power 1. So 1 minus 1, 3x square plus y square, 3x square plus 2y y dash x square sorry, here only x is here. Here only x, then derivative will be here. What? 3x square plus x1 y square plus x into 2y y dash, this. Okay, so from here we can take common, it is our minus x. If the minus x is common, then minus x cube minus, because if we put if the minus is common, then minus sign is here. So minus x cube minus xy square plus 3x square plus y square plus x 2y y dash. So we can see that this is the derivative. Now x equals to 0. Okay? So if x equals to 0, then its value is 1. It is a minus 0, 1. Here, x is 0, and y at 0 equals to what? Here y y at 0 equals to 1. So when we put x equals to 0, so this is 1, 0, 0, 0, this is 1. So 1 into 1, 1. So this implies y double dash 0, 1. Similarly, you have to find triple dash. Similarly, you have to find triple dash. Just differentiate it. Okay? So, that's lengthy expression will be okay. So, you can write e to the power minus x and derivative of all this. First of all, suppose we take first function as it is and differentiation of this. And differentiation of this, because again differentiate it. So you have to differentiate successively. That is the main level, okay? So here, minus 3x square, here, xy square is here. So you can differentiate. Clear? So after differentiation, you will get like just like this. Write it. I am only writing this, okay? Doing this process, okay? This is first function, this is second function. And you can differentiate it. Taking first function, then differentiation of second, plus differentiation of first function, and as it is second function. Then just e to the power minus x is common. Just take it is common. You can write the derivative like this. Just here, see. After taking e to the power minus x, you can write like this. Minus x cube minus xy square. Minus x cube minus xy square plus 3x square plus y square plus 3x square plus y square. Just differentiation of this we see here. Okay. Just differentiation of this is this, and now as it is. Okay. 2x plus 2xy y dash this plus just differentiation of this by taking it as it is e to the power minus x. And e to the power minus x is common. So here just this will be plus sign. So 3x square, 3 sign will be changed because minus is common. So 3x square plus y square plus 2xy dash, 2xy dash minus 6x minus 6x minus 2y dash minus 2xy dash square minus 2xy dash square minus 2xy dash square minus 2x y dash this. Okay. So this is differentiation, third order differentiation. And from here, just x equal to 0, we can get y third derivative at 0 equals to minus 2. Just you can calculate and see. So this is Taylor series method. Taylor series method what says? Just first derivative is given, second derivative, third derivative, just all the values you have to find at about the point 0 point. This point, this point, this point. And put these values here for this particular values, because about this point, so about origin, so we can write y0 equals to 1, 1 plus here x into y0 dash. Y0 dash is 0, so this is 0 plus x square y 2, factorial means 2, y double dash 0, 1, so this is 1 plus here x cube by 3 factorial 6, y triple dash minus 2, and so on. Just you have to calculate by taking this value yx. This is used for finding value of y at this point. Expansion about this. For finding the value of y at this point, you have to find the derivatives at this point. If we expand about this point, then this point will be 0. Point will be what? 0.1. Then we can get the value at y2. So from here, put implies what? Y. X means first value 0.1. Just put x equal to 0.1 here. So we can 1 plus is 0 plus 0.1 square upon 2 into 1 plus 0.1 cube upon 6 minus 2. Just calculate it. Okay. .005. So you can find 1.005. This is the value of y1. That is y.1. y1 because at x1. This is y1. So just y0, y1. Similarly, we have to find the value of y2, y3 from this formula. We can use this formula directly for finding the value of y2 and y3, but value will be accurate if we use for this is origin point, that is about point. Then we can find more accurate value of y2. So here just note down all the values. Okay, just we can now for next stage for y1, this is for y2. For y2, yx equals to what? Y here 0.1 because at this point 0.1 plus x minus 0.1 upon 1 factorial y dash 0.1 means y at 0.1. Y at 0.1 we know what this, and y dash at 0.1 just put 0.1 in place of x, then you can get y.1 dash, and y.1 means this value. So just previous value. Then the value of y will be more accurate. And you can also use direct this value. Just put here x.0, 0.3, you can get the value. But this is main step for more accuracy of the point y2, y3 by Taylor series method. Okay, if we expand about this point, then formula will be like this. Now this is origin. About this point, we have to expand the formula for this. So here, what? X minus 0.1 square by 2 factorial y 0.1 double dash plus similarly x minus 0.1 cube by 3 factorial y triple dash at 0.1 and so on. Clear? So from here we can get value of y at 0.2. The next point as x equal to 0.2, here y.1 is this 1.005 plus x means 0.2, 0.2 minus 0.1, 0.1. So 0.1, 0.1, okay. This is point 1 here. This can be found from putting here. Just you have to put point 1 x in place of x and in place of y 1.005. You can calculate that value is 0.092. Just you have to calculate by using calculator. Okay, 0.092 plus x equals to 0.2 minus 1, 0.1 square. 0.1 square upon 0.1 square upon 2 factorial 2, and this value just in this formula, second derivative, just in place of x just write 0.1 and in place of y just write 1.005. You can get the value derivative. Very tedious work because there are many values, so you can computerize this. Okay, so here 0.849, this is 0.849 plus here also just like this 0.1 cube upon 6, and just finding third derivative. Third derivative minus 1.247, minus 1.247. Just up to this, calculate it. You can get what? y2 equals to y 0.2. Okay, this is y2, this is y1, this is y2. At y2 the value is 1.018. 1.018. Clear? Y2. Now, in a similar process, we can get y3 by taking 0.2 in place of here. 0.2, 0.2, 0.2, 0.2, 0.2. Then 0.3, that means you can also write the formula. Now, similarly, just calculate it, okay? Just here take point in place of 0.1, 0.2. For 0.2 you can get all the values. Y for 0.2? This. And you can get all the derivatives. Put here. Then you can get similarly y3 equals to. Just I am only writing y similarly. You can find y3 equals to y 0.3 is equals to what value? 1.04. 1.04. 1.04. So this is three value. Okay. y1 is here, y2 is here, y3 is here. Three value and one is value. So four value we found. Okay, now using these four values, we have to predict the value of y4 by Milne's formula. Clear? So just use Milne's formula here. This finding these values y1, y2, y3 by using Taylor series. You can also find from Picard's method. You can also find from Euler's method, Euler's modified method, and also from Jagdalpur method. Just find three values. And finally, we have four values. Just use these four values for predict the value of y4. First prediction, then correction. Okay. So now we will use Milne's prediction formula for this y4. Okay. So here, just you have to write like this. Now, the starting four values, starting values of the main, starting values of Milne's method. Starting values of Milne's method, okay, with method are what? X0 equals to what? 0, 0.0. X1 equals to 0.1. X2 equals to 0.2. X3 equals to 0.3. X4 equals to, just at X4 we have to find the value. Okay, these four values are required. So this is first value, and this three value we have find for corresponding value of y0 is 1, y1 is equals to y2 equals to y3 equals to. For prediction correction formula, we are requiring the values, four values. Here at this point, just we have to find, we have already find the values, just of y1 1.005, and second second is what? 1.018, 1.018, and 1.04. 1.04. These are the values. Just by Taylor series method, we are getting these values. Okay, we have already got these values. Okay, now for prediction formula, we require f0, f1, f2, f3. So just find f0, f1, f2, f3. Okay. F1. Now F0 equals to what? F0 equals to means y, x0, y0, y0, 1. Here fxy equals to, here h equals to 0.1 and fxy equals to x square plus y square e to the power minus 6. Clear? Now here f0 means what? F x0 y0, and it can be calculated. How? f0 1, that is here f0 1, x0 0, f0 equals to 0. Okay, so f0 equals to 0. Clear? 0. Now f1 means what? F x1 y. F x1 y1 means what? F x1 means 0.1, and y1 means 1.005. Okay, x1 y1. Just use here. Then by using this formula, you can get f 0.1, 1.005 equals to what? 0.1 into x square plus y square. That means x means 0.1 square plus 1.005 square into e to the power minus 0.1. Just calculate it using calculator. You can find this value. This square plus this square, and this e to the power minus of this. Find the value from calculator. Just write here. So that will be the value of here f1. What is the value? 0.092. 0.092. Okay, you can get it from this formula 1 by 1. Similarly, here f2 can be found by using 0.2, 1.018, 0.2, 1.018, just like this. 2, 018, 2, 2, 018, 2. And calculate it. You can get the value F2. F2 equals to 0.176. 0.176. Similarly, F3 can be found. F3 is 0.26. 0.26. So these are the values, required values. First of all, we have to find these values by Taylor series. And now find F0, F1, F2, F3. Now using predictor formula. Now we have to find the value y4. In these questions, we have to find the value y at 4. This is our requirement, main requirement, 0.4. Just next value. Okay. So now using prediction formula. Now using prediction formula. Due to Milne's, we get y4 prediction value. We have to find the value of y4. So prediction value y4 p equals to what? We know formula y0 plus 4h by 3 0 2 f1 minus f2 plus 2 f3. This is our prediction formula due to Milne's. Just use all the value f1, f2, f3, f1, f2, f3. These values will be used here. H equals to 0.1, h equals to 0.1, and y0 equals to this 1. Just use this value, you can get the value. Okay. So right, just for lack of time, so just I am not writing here values, just calculate it. Here put 1, h 0.1, then and f1 to 3 are this. Just put here and calculate. You can get the value just like 1.09. Okay. So just 1 plus 4 into 0.1 upon 3. Here 2 into f1 0.092. Okay. Minus f2. F2 means 176 plus 2 into 0.26. This. Okay. This type of values here, and solving 1.09. Just 1.09. Solve it 1.09. This is prediction value of y4. Therefore, x4 equals to what? What happened? x4 equals to 0.4. And y4 prediction value is what? 1.09. So now for this x4, y4, we have to find f. So implies f4 equals to, just you have to find f4 equals to. f4 equals to what? f4 equals to, here, f of what? 0.4. 0.4. y4. Use this value, predicted value. Then we can get value from this formula. This formula. Okay? Just like this. 0.4 square plus 1.09 square e to the power minus 0.4. Just calculate it. 0.362. 0.362. This is f4. Now we will correct this value. This is prediction formula. Now we will correct this value of y4. For correction, we will use the value f4 because correction formula. Now using correction formula due to Milne's, we get what? y4, we have to correct this value first time. First correction was y2 plus h by 3 f2 minus, not minus, plus I think, okay, plus f2 plus 4f3 plus 4f3 plus f4. Here f4 is what? This f4. So just put value y2. What is y2? This 1.018 plus h 0.1 upon 3. f2 is this 0.176 plus 4 into f3 is this 0.26 plus f4 is this 0.362. Okay, and this can be solved. Just calculate it. You can get the value as 1.071. 1.071. Okay, so this is first correction value. You can repeat it, but for repeating, take x4 equals to this at 4, x4 equals to this, and y4 equals to this. Clear? And use here. Find f5, f4, and again use that f4 in this formula. Repeatedly you can use this formula here, and you can correct value 1 time, 2 time, 3 time, 4 time. Okay, so 1.071 is the first correction. You can get second correction, third correction, whenever two correction are same value, that will be the answer. So this is the prediction and correction due to Milne's. Okay, first of all we are getting these values from any of the formulas. 4 values. These 4 values are used for prediction of the next value of y, and after prediction just find the value of f and use correction formula, and you can use successively this correction formula for first correction, second correction, third correction, fourth correction. For second, this is first correction. For second correction, formula will be used this. Only f4 will be changed. Only f4 will be changed. Clear? For second, this first correction. Okay, y4 c. This is first correction. You can use notation. This is first correction, second correction, third correction, fourth correction. And when two corrections are same, give the same value, then we can say that it is the final answer. Okay, so this is first correction. Clear? For each correction, use previous f4. Just using this y4 and x4, you can get value f4. That f4 is used for next correction formula. Formula is this. Okay. So this is correction formula, prediction and correction formula due to Milne's. Okay, and these values, previous values can be found by Ranga-Gupta method Euler's method, Euler modified method, Taylor's method. Generally, we are using Taylor's method if this function is simple, or Ramagupta method also can be used. So, use any of the method for finding real values, and after getting 4 values, just we have to use prediction correction formula. Clear? So, solve this question. Just I am giving here in questions. Here, just first 3 values you have to find using Ramagupta method, and then next value you have to find by using prediction correction formula of Milne's prediction correction formula. Okay, so this questions is for your attendance. Just do it complete by using calculator, because this method, this type of method can be also computerized, Okay, so because same type of process, we should then do in the next every interval by using previous value from previous interval. So there is a heavy work for calculating if we use calculator. So this type of method can be computerized. Generally, numerical mathematics, the method of numerical mathematics can be done through program on computer, so that will be very easy for calculation, because computer can do very fast. Now you can use calculator and solve the following, the given questions, that is using Ramagupta method of order 4. Ramagupta method, generally Ramagupta method means 4th order Ramagupta method. Okay, so we know Ramagupta method. By using that method, we can find the previous 4 values. Here, find y for x equals to 0.1, 0.2, 0.3. Given that dy by dx equal to xy plus y square, y0 equals to 1. Calculate the solution at, continue the solution at 0.4 Milne's method. Here, just in this question, simple. First, given, here also given y equals to 0 at x equals to 0. That is, x0 is 0. In this question, just see what values are given. x0, 0. x1, x2, x3, and y0, 1. I think y0, 1. Okay, y0 what? 1. Okay, and we have to find y1, y2, y3. Just these 3 values we have to find from Ramagupta method. Okay, and then for these 3 values, that is y1, y2, y3 means 0.1, 0.2, 0.3. Okay, this is 0, 0.1, 0.2, 0.3, and we have to find, we have to predict y4 and then correct y4. Okay, prediction and correction. Prediction and Milne's prediction to y4 and Milne's correction to y4. Just this prediction and correction, but y1, y2, y3 are we will find from Ramagupta method. Here it is given also that what? Dy by dx equals to x y plus y square, I think. Xy plus y square, okay? Xy plus y square. That is what? Fxy equals to xy plus y square. And h equals to what? 0.1. Because 0.1, 0.2, 0.3. That is the. And by using Ranga-Katta method, we can find the value of these three. Ranga-Katta method what? Just find k1, then k2, then k3, and then k4, and then k equals to 1 by 6 of k1 plus 2k2 plus 2k3 plus k4. This is the value k, therefore y1 equals to what? y0 plus k in each stage. Ranga-Katta method. Okay. This is Ranga-Katta method. K1, we can find the K1. K1, how can we find K1? F x0 y0. x0 y0 means what? 0 1. F0 1. From this we can find this value. Then F, what? x0 plus half h and half y0 plus, here y0 plus half k1. Here f x0 plus half h, y0 plus half k2, and here h f x0 plus h, y0 plus k3. Just find all the values. You can get this all the values from this formula. So k1, k2, k3, k4 you have to find, and then start in first test here, just like this, na? Here 0, here 0.1, here 0.2, here 0.3, here 0.4. This is our targeted value, y4. Okay. For this, we are using what? Ranga-Katta method. For this, 0.1, for this, x1, y1, use this. And for this stage, this will be the previous value here. x1, x1. And for this stage, here x2, using previous value. And by using this, we can get all the values. And finally k equal to this, and then this is equals to the value. Put the value of k, y0 plus this. You can get values here. And now using this value, you can get f0, f1, f2, f3. And this value can be used here, y0 plus what? y0 plus 4h upon 3 here. f1 minus 2, f2 plus f3. This is prediction formula. Correction formula is y2 plus h by 3 here, f2 plus 4, f3 plus f4. Okay. So prediction formula is, you can use just correct the value 2-3 times for these questions. Okay. So the last questions, just I have done only one correction. You have to do 2, 3, 4 corrections. How can you correct it? First of all, just by Ranga-Katta method, at each stage, this, use this process one by one. First this, in this process, then you can get it. Again use this at this stage by using this x1, y, x2, y2, x1, y. And then for this x2, y2, just you can get this three value. So f0, 1, this equals to from there. This you can get f1. This you can get f2. This you can get f3. Now first prediction, f1 minus 2, f2 plus f3. Sorry, yeah, just like not this 2 here, 2 here 4. Okay. F2 plus 4F3 plus F4. F2 plus 4F3 plus F4. F2 F1 minus F2 plus 2F3. 2F1 minus F2. 2F1 minus F2 plus 2F3. Just use this formula. Okay. Now F1 to F1 F2 F3 y0 y0. You can predict the value. And here what x0 equals to x4 equals to x4 equals to 0.4, and this is y4. For this x4 and y4, just use find f4 by using this, and use this f4 here, and f2 f3 f2 f3 f2 f3 f4 is this, and y2 this, and this is with the first correction. This will be the first correction, that is first correction. Okay, first correction. And just after first correction, use this x4. Use this x4, 0.4, and use this value of corrected value. By using this value, again find f4. Again find f4. And now, second correction. Again use this formula. Again use this formula. Y4, see, first correction, this second correction. Again use this formula. Y2, F2, F3 are this. But F4 will be this way. This way. Clear? So again use third correction. Whenever two correction gives near about same value, that will be the answer. Okay? So 2-3 corrections you have to do. First correction, second correction, third correction. Just do at least 3 correction. Okay? This is first correction, this second correction, this third correction. For second correction, use this formula totally, but F4 will be new by using this X4 and this Y4. You will get F4, again new F4 from this formula. Okay? So just getting F4 and just do the correction. After 3-4 steps, you can see that near our two values are same, that will be our answer. Okay? So do this very carefully by using calculator and send me PDF file for your attendance. Okay? So this is the prediction correction, Milne's prediction correction method. Okay?